we have a video this time on significant figures or Sig Figs or significant digits, all the same thing. I'm not a huge fan of these, but they're good to know and end up coming up on the ACT and SAT. But this is what we need to know. Here's the trick. If you measure something, you can't be more accurate than what you measure. So that's the trick. So if we measure something, say we want to accuracy to maybe 0.1 decimal places, we can't report an answer that's accurate to like the 0.00001 decimal place, right? Like plus or minus this is much different than plus or minus this. So that's the general idea of where this comes from. So there are some rules and some things are confusing, but let me give you an example. Maybe it might make a little bit more sense. If you have, I don't know, some kind of box, right? Awkwardly drawn box. And you happen to know the volume of this. Alright? So maybe the length 4.55 centimeters. The width 9.0 centimeters. And the height 2.54 centimeters. So my volume for a cube is equal to the length times the width times the height, which easy 4.55 centimeters times 9.10 centimeters times 2.54 centimeters. Awesome. Put that onto a calculator and I get 105.1687 centimeters cubed. Done, right? Like there's a good number. That's pretty accurate for what I got. But when I look back, the ruler I used to measure something, if I was measuring 2.5, and here's a 2, here's a 3, here's 2.54. My ruler only measured this much, right? For example, it didn't measure out to the 2.5400 decimal place, and it's only 4. These are 4 decimal places. Here's only 2. So obviously this number is more accurate, but I can't measure that precisely with this ruler that I used to measure this cube with. So we count the number of significant figures. Number 1, non-zero. It's not 0, digit is significant. So I'm going to put sig as significant. Number 2, any 0 between 2 significant figures. Well, that's significant. 3, a 0 to the right of both a significant figure and the decimal. That's significant. That's confusing. That's saying that if I have this as a measurement, there are 4 total Sig Figs here. Right? It's to the right of both keyword both, and the decimal. So here's your significant because it's a non-zero digit. Here's decimal, so both of those are significant. Let's look back at our question here. How many significant figures do we have here? 3. Here, same thing, 3. Here, 3. So our answer, if we're multiplying, needs 3 significant figures. If we're multiplying, we use the least, let me put it over here. If you're multiplying, or dividing, sorry, my pen doesn't work very well toward the edge. Multiplying or dividing, we use the least number of sig figs. So our least number is 3. We would use 3. Our answer needs to have 3. So how do we convert this to 3 significant figures? Well, let's start with our first number, 1. Significant, yes. 0, is that significant? Well, it's between a 1 and a 5, so because of rule number 2, any 0 between 2 significant figures is significant. So right there, that is 3 significant figures. Units. So here is a more accurate answer if we use significant figures, which we will. I'm not saying that this is the wrong answer. This is just an answer that is not considered, but is considered more accurate than the measurement used. Just a hint here, this is not decimal places. They're often confused, but they're not the same thing. This is significant figures, not decimal places. All right, good luck.